Welcome back. Last time, we dove into some of the core strategies that have been shaping language model performance recently. Remember how we explored the chain of thought, CoT method, and speculative decoding, SpecDec, both? Both were pretty big steps forward. Core-T gave us that step-by-step prompting approach to boost reasoning accuracy, especially with tailored examples, while SpecDec was all about speeding things up without sacrificing quality. Today, we're building on those foundations with something quite different but equally exciting.
Yeah, and if I remember correctly, COT required a lot of manual setup to design specific examples for each task, right? It was effective but a bit labor-intensive. And SpecDec improved efficiency but didn't actually tackle reasoning itself. So, this episode seems to bring together those strengths in a new way.
Exactly. Today's focus, Zero-Shot Chain of Thought, or ZS-CoT, takes CoT's step-by-step prompting concept and simplifies it massively. What makes ZS-CoT remarkable is how it achieves structured reasoning without task-specific examples. Just one simple universal prompt, let's think step by step, and it's able to handle diverse reasoning tasks. This paper essentially proposes a task-agnostic solution, so there's no need to craft unique prompts for each new problem type.
That's really intriguing, especially for anyone working with LLMs who wants to streamline their applications. I guess ZS-CoT's approach could mean less time setting up and more time actually solving problems, right?
Exactly, and that's why this paper is such an important one. ZS-CoT also taps into something exciting about large language models, their inherent reasoning potential. It's almost like these models have hidden capabilities that just need the right nudge, without complex prompting or example engineering. Plus, the gains on reasoning benchmarks are significant compared to standard zero-shot techniques.
So, we're not just talking about a more convenient method. ZS-CoT actually performs better on benchmarks too. Sounds like a game changer for anyone interested in expanding model applications without all the manual setup.
Absolutely. In this episode, we'll walk through each part of the paper to understand how ZS-CoT works, the experiments that validate its effectiveness, and the ways it redefines efficiency and versatility in prompt engineering.
Perfect. I'm ready to see how this all fits together and what it might mean for the future of prompting and LLM capabilities. Let's dive in.
Today, we're looking at the abstract of a study on large language models, LLMs, and their ability to perform reasoning tasks without specific examples, or zero-shot. This study primarily explores how LLMs can handle complex reasoning, like arithmetic and symbolic tasks, by adding just a single prompt. Let's think step by step. By doing so, it claims to improve reasoning performance significantly, showing that LLMs can approach these tasks without custom-tuned step-by-step examples. The authors call this approach Zero-Shot-CoT, or Zero-Shot Chain of Thought. Do you want to break down how the Zero-Shot-CoT technique works, or the performance improvements it mentions?
I'd like to know more about how this, let's think step by step, prompt impacts reasoning. It sounds simple, but does it really make such a big difference?
Great question. Yes, surprisingly, this prompt encourages the model to generate multi-step reasoning, which it wouldn't typically do in zero-shot mode. Usually, complex reasoning tasks are more challenging for LLMs, which often only excel in direct, single-step questions. With this prompt, though, the LLM begins to think aloud, laying out its thought process one step at a time. For instance, in arithmetic problems, instead of jumping to an answer, the model outlines calculations, which boosts accuracy.
Interesting. So this single prompt shifts the LLM from giving immediate answers to reasoning through steps. How much of an improvement did it lead to?
Yes, exactly. It encourages structured reasoning. In terms of improvements, they tested Zero-Shot-CoT on various reasoning benchmarks. For example, it increased accuracy on the multi-arith dataset from 17.7% to 78.7%, and on GSM-8K from 10.4% to 40.7% using a large Instruct GPT model. The same prompt also worked with another large model, PAL-M, giving similar boosts. These jumps are particularly impressive because they're achieved without tailored step-by-step training examples.
That's a huge difference. Does the Zero-Shot-CoT work for reasoning tasks other than arithmetic, like logic or common sense?
Yes, they applied Zero-Shot-CoT across various types of reasoning tasks, including symbolic and logical tasks, like determining the last letter of a word sequence or tracking objects in a shuffled order. It showed strong gains in symbolic reasoning and logical tasks, but had mixed results in common sense reasoning tasks. It suggests LLMs have more untapped potential in structured reasoning, while common sense tasks might still need more contextual or world knowledge.
So, it's like this method taps into some core reasoning ability of the LLM. Does this mean LLMs could handle a broader range of tasks with just the right prompting?
Precisely, and that's one of the study's conclusions. They argue that this simple, task-agnostic prompt might reveal broader reasoning abilities in LLMs, hinting at higher-level cognitive potential within these models. Essentially, it suggests that complex, multitask reasoning could be elicited with minimal adjustments, encouraging more exploration into zero-shot capabilities before resorting to fine-tuning or complex prompts. All right, let's dive into the introduction. This part sets the foundation, explaining how the field has evolved to focus on large language models, or LLMs, for natural language processing tasks. The authors highlight that scaling up model sizes has been a game changer, moving from models with a few million parameters to those with hundreds of billions. This massive scaling has enabled models to perform various tasks in a zero-shot or few-shot context. Have you heard of these zero-shot and few-shot methods before?
Yes, I think so. Zero shot would mean the model isn't given any specific examples before solving a task, right? And few shot would mean it gets just a few examples as a reference?
Exactly. Zero-shot is when the model gets only a description of the task, no examples at all. Few-shot is when it's given a few examples in context before solving a new one. The power of LLMs like GPT-3 and PAL-M largely comes from these abilities to generalize from little or no specific data, just through a well-designed prompt. Now, prompting itself, essentially providing structured text to steer the model's response, has become quite central. What do you think might make a prompt more effective?
Maybe the clarity of the instructions? Or making the prompt more task-specific so it aligns better with what the model needs to do.
Spot on. The effectiveness of a prompt often depends on its clarity and relevance to the task. Clear prompts allow the model to understand what's expected, and task-specific prompts can make responses more accurate. But this study is a bit different because they explore the potential of a very simple and broad prompt. Let's think step by step, which they use in a zero-shot context for reasoning. They argue that this single prompt alone can unlock reasoning across various tasks. Any thoughts on why that might work?
Maybe because breaking things down step by step makes it easier for the model to process each part logically. Instead of jumping to an answer, it can consider each part of the problem in sequence.
Exactly, you've got it. By prompting the model to take things step by step, it essentially creates a thinking process, allowing it to outline its logic before reaching an answer. This is called chain of thought reasoning. Typically, chain of thought has been used in a few-shot format, where multiple examples demonstrate how to break down the task. But here, they're experimenting with chain of thought in a zero-shot setting, seeing if a single general prompt can produce logical steps without those specific examples.
So, they're aiming to show that even a general prompt can lead to reasoning capabilities without the model needing task-specific training?
Yes, exactly. That's the central goal. The authors suggest that LLMs might have a broader reasoning capacity that we can tap into simply by guiding them with the right kind of prompt. This approach of Zero-Shot-CoT, or zero-shot chain of thought, challenges the idea that complex reasoning tasks always require tailored, step-by-step examples for best results. It opens up possibilities for developing more universal prompts that could apply to multiple reasoning tasks. Now let's get into some of the background to better understand where this zero-shot chain of thought idea is coming from. To set the stage, the authors first discuss large language models, or LLMs, and how these models are fundamentally changing natural language processing. The scaling of model sizes has been huge, from a few million parameters to over 100 billion. This shift has allowed LLMs to perform many tasks with minimal or even zero specific examples. And to make that happen effectively, we have something called prompting. Familiar with prompting?
Yes, prompting is like setting the context for the model, right? Giving it an example or instruction to shape its response.
Exactly. Prompting is a way to guide the model's responses by framing the input to align with what we're looking for. And in the zero-shot case, there are no specific examples, just a well-chosen template or instruction. Recently, as these LLMs have grown, prompting has shifted from the classic pre-train and fine-tune approach to more of a pre-train and prompt strategy. By just giving these models a template, we can get them to perform well on various tasks.
So, the idea is to avoid specific training for each task and instead rely on prompting for versatility. That's efficient. How does this connect to multi-step reasoning, though?
Good question. This brings us to a technique called chain of thought, or COT, prompting. It's mainly used in few-shot contexts and is particularly useful for reasoning tasks that require several steps like math problems or logical sequences. COT prompting involves showing the model step-by-step examples during the prompt, encouraging it to follow a logical process before giving an answer. This approach has shown to work especially well with very large models.
So, COT prompting is about guiding the model to reason step by step. But how is it typically applied in few-shot settings instead of zero-shot?
Right, usually COT was implemented in a few-shot way. This means the model is provided with multiple examples that illustrate each step of the reasoning process. Those examples act like a guide. But the authors here wanted to see if a similar multi-step reasoning could be prompted in a zero-shot setting, without any examples. So they tried to generate chain of thought with just a simple instruction. Let's think step by step. Their goal is to see if that single instruction could unlock the model's reasoning abilities without needing a customized example set.
It sounds like they're testing if the model has built-in reasoning skills that just need the right prompt to be activated. That's intriguing. If this works, it could mean a lot less work to create prompts for each new task.
Yes, exactly. This idea is at the heart of Zero-Shot-CoT, or zero-shot chain of thought, which they propose in this paper. They're suggesting that large models might have latent reasoning capabilities, which we can activate simply by prompting them in the right way, rather than building and training on task-specific examples. All right, now that we understand the basics, let's get into the core idea of this study: zero-shot chain of thought, or zero-shot-CoT. This approach builds on the chain of thought prompting but simplifies it to a single zero-shot prompt. Instead of using examples to teach the model a reasoning path, Zero-Shot-CoT uses a simple instruction like, let's think step by step. The goal is to prompt the model to generate a reasoning process for itself. Are you with me so far?
Yes. It sounds like they're aiming for a minimal approach. Instead of a detailed setup with examples, they're testing if just one general instruction can encourage logical steps. How does this differ from standard prompting approaches?
Good question. Standard prompting typically provides either direct questions and answers or a few specific examples. But Zero-Shot-CoT is about prompting reasoning without examples. It's a single instruction that aims to trigger the model's internal reasoning capabilities across various tasks. To get the answer, the model has to reason through the problem step by step rather than giving an immediate response.
So they're challenging the model to take on a more complex process with minimal guidance. What kinds of tasks do they apply this to, and does it actually improve performance?
Yes, exactly. It's like nudging the model to think aloud. They tested Zero-Shot-CoT on diverse reasoning tasks like arithmetic, symbolic logic, and common sense reasoning. And the results showed some impressive improvements for a sequence. For instance, on arithmetic problems from datasets like Multi-Arith and GSM-8K, the model's accuracy increased significantly when using the Zero-Shot-CoT prompt compared to a regular zero-shot prompt.
Interesting. And I imagine this also highlights that LLMs might have more underlying reasoning ability than we thought. How well did it do compared to the few-shot approach, though? I'd think using specific examples would be more effective.
You're spot on. The few-shot approach, which uses carefully chosen examples, generally performed a bit better because it provides tailored steps for the model to follow. However, Zero-Shot-CoT still showed a huge boost over the traditional zero-shot prompts. It didn't quite match the accuracy of Zero-Shot-CoT with custom examples, but did very well considering it required no extra setup per task. This shows that large LLMs can tap into multi-step reasoning without handcrafted prompts, just from a simple instruction.
That's impressive. So, the key finding here is that a well-designed prompt alone might unlock reasoning in ways we haven't fully leveraged yet.
Yes, absolutely. The authors suggest that this could point to an underlying general reasoning ability in LLMs, which can be triggered with the right type of prompt. It's a very promising step toward more versatile, low-effort prompts that don't need extensive customization for each task type. So now that we've covered the basics of zero-shot chain of thought, let's look at the experiments conducted to test this approach. The researchers evaluated Zero-Shot-CoT on 12 different datasets covering various reasoning tasks, including arithmetic, common sense, symbolic, and other logical reasoning challenges. Each dataset was chosen to push the model's reasoning abilities in a unique way. Are you ready to dig into how these tasks were set up?
Yes, I'm curious about how they ensured that each dataset was suitable for testing Zero-Shot-CoT. Were these well-established tasks, or did they have to create new ones?
Good question. Most datasets were established benchmarks commonly used for reasoning evaluation in language models. For example, they used multi-arith and GSM-8K for arithmetic reasoning, which contain multi-step math problems. Other tasks like Common Sense QA test common sense reasoning, requiring the model to answer based on prior knowledge or implicit information. For symbolic reasoning, they included tasks like last letter concatenation, where the model has to pick out and concatenate the final letters of given words. They also had a coin flip dataset which tests logical consistency by having the model track whether a coin stays heads up after multiple flip or no flip commands.
So it sounds like they have a mix of easy to hard tasks to really stretch the model's reasoning abilities. Did they compare Zero-Shot-CoT to traditional zero-shot prompting to measure effectiveness?
Exactly. They compared the standard zero-shot prompting to Zero-Shot-CoT on each dataset. The results were pretty compelling. On several tasks, Zero-Shot-CoT significantly outperformed regular zero-shot prompts. For instance, in arithmetic reasoning, it raised the accuracy on multi-arith from 17.7% with a traditional zero-shot prompt to 78.7% with Zero-Shot-CoT. On GSM-8K, another challenging math dataset, accuracy jumped from 10.4% to 40.7%. That's a massive improvement, simply from adding a let's think step-by-step instruction.
That's impressive. I guess it shows how much potential is hidden in these models, which a simple prompt can unlock. What about common sense or symbolic reasoning? Did Zero-Shot-CoT also make a big difference there?
Yes, it did, though the improvements were varied. For common sense tasks like Common Sense QA, the gains weren't as high as in arithmetic tasks, but Zero-Shot-CoT still helped. In symbolic reasoning, the results were particularly strong in tasks requiring systematic tracking, like last letter concatenation and coin flip. For example, in the coin flip task, accuracy improved dramatically because the step-by-step prompt encouraged the model to follow each step logically instead of skipping to an answer.
So it seems that Zero-Shot-CoT might be especially effective in tasks where step-by-step logic is essential, while common sense tasks might need more contextual information. Did they notice any model-specific behavior, like performance differences between smaller and larger models?
Yes, they did observe model size effects. Larger models like Palm 540B and GPT-3's Text DaVinci 002 achieved the most noticeable improvements with Zero-Shot-CoT, especially on complex reasoning tasks. Smaller models, on the other hand, struggled to leverage Zero-Shot-CoT as effectively. This suggests that chain-of-thought reasoning benefits more from models with larger parameter counts, likely because these models have more capacity for processing and retaining complex multi-step sequences.
So, larger models seem to have a natural edge when it comes to reasoning prompts. I guess that makes sense since they would have more resources to think through each step.
Exactly. And that's a big takeaway from this study. The Zero-Shot-CoT approach not only reveals an untapped reasoning potential in these large models, but also suggests a pathway to design prompts that could scale up LLM performance across multiple types of reasoning tasks. All right, now we'll discuss the broader implications and related work surrounding zero-shot chain of thought. The researchers here wanted to highlight how Zero-Shot-CoT offers a more efficient way to elicit reasoning in language models without requiring custom examples. They reference other studies that have tried prompting methods, like few-shot prompting and task-specific tuning, which often improve reasoning but require more setup. Any thoughts on how this compares to the approaches we've talked about before?
It seems like Zero-Shot-CoT has the advantage of simplicity. Instead of creating detailed prompts or training data for every new task, it just needs that one generic instruction. But I imagine that other methods, like Few-Shot-CoT with tailored examples, would still offer higher accuracy.
Exactly. Few-shot prompting with tailored examples generally performs better because it provides explicit guides for each step. But the key point here is that Zero-Shot-CoT still achieves substantial gains without those extra steps, which makes it a more scalable option for multiple tasks. And in their experiments, Zero-Shot-CoT performed consistently well across various reasoning benchmarks, indicating a kind of general-purpose reasoning boost that few-shot examples might struggle to achieve without customization.
It sounds like they're pushing the boundaries of what we can achieve with minimal prompting. Were there any notable studies they referenced to contextualize their approach?
Yes, they referenced several. For example, Wei et al. 2022 worked with Few-Shot-CoT, showing how step-by-step examples could improve multi-step reasoning tasks. Another notable study by Reynolds and McDonnell, 2021, showed that even a simple prompt like, "Let's solve this problem by splitting it into steps," could enhance multi-step reasoning in certain arithmetic tasks. However, those approaches involved examples or complex prompt engineering tailored to specific tasks. Zero-Shot-CoT instead opens up reasoning with a single, general instruction across various tasks, like common sense and symbolic reasoning, with no need for task-specific adaptation.
That's a big shift from traditional methods. So, instead of focusing on model fine-tuning or extensive prompt engineering, they're relying on the model's own potential to generalize reasoning through minimal guidance.
Yes, and they suggest that this might hint at some underlying reasoning ability within large models that hasn't been fully tapped into. The performance gains with a single instruction like, "Let's think step by step," suggest that large models, especially those scaled up to billions of parameters, may have a more generalized cognitive capacity than previously assumed. This kind of broad reasoning ability hasn't been fully explored, and they hope their work will encourage more studies into zero-shot reasoning capabilities. All right, to wrap up, let's summarize what the study's conclusion tells us about the zero-shot chain of thought approach. The researchers proposed Zero-Shot-CoT as a minimalist way to engage chain of thought reasoning across a variety of tasks without relying on specific handcrafted examples. They positioned this method as the strongest zero-shot baseline for complex, multi-step reasoning tasks that previously challenged large language models. Impressive, right?
Yeah, it really is. They managed to unlock a form of reasoning with just one simple prompt instead of extensive setup. So, they're essentially saying this could be a baseline for future prompting techniques?
Exactly. They suggest that this approach can serve as a foundation for developing other versatile prompts that target broad reasoning abilities rather than just task-specific skills. By creating prompts that encourage LLMs to think step by step, they're showing that large models have more potential for generalized cognitive tasks than we previously thought. It's a promising step towards simplifying the use of LLMs for complex reasoning. And that wraps up our deep dive into zero-shot chain of thought. It's amazing to see how a simple prompt like, "Let's think step by step," can unlock such powerful reasoning abilities in language models, right?
Absolutely. It's impressive how ZS-CoT brings a whole new level of efficiency and versatility. I keep thinking about how it could simplify applications across so many fields without needing specialized prompts for each task.
Exactly, and beyond just simplifying, it really challenges our assumptions about what these models are capable of with minimal guidance. Plus, seeing those benchmark improvements really shows how impactful this could be.
Totally. And I think it raises a lot of exciting questions, like what other hidden capabilities might we be able to tap into with different simple prompts? And could there be even more universal prompts waiting to be discovered?
Great points. We'll definitely keep exploring these kinds of innovations as they evolve. Thanks to everyone for joining us today and diving into ZS-CoT with us.
Yes, thanks so much for listening. Until next time, Keep those prompts simple and effective.